Welcome to Academic Guru's Tutoring Tuesday, where we answer all of your high school, college, and university questions. If you would like your question to be featured on next week's Tutoring Tuesday, please submit your questions to questions@academicgurusinc.com. Don't forget to subscribe so you can stay current with all of our new videos. Today I'll be solving a physics question involving distance, speed, and time. And the question reads, Sarah runs several times a week and always keeps track of how much time she runs each time she goes out. One day she forgets to take her stopwatch with her and wonders if she can still have some idea of her running time. As she passes a particular point, she remembers that it is 5.6 kilometers from her house. She knows from her previous training that she has a consistent pace of 3.4 meters per second. How long has Sarah been running when she reaches the pond? Now, as always, I'll be breaking this question down into steps, with the first step being to understand the question. So here we have a pretty long word problem, and at first glance it can be pretty intimidating. There's a lot of stuff going on, and the main thing to consider whenever you come across word problems is to identify the key parts to what I refer to as the puzzle. I see word problems as puzzles, and you're usually given clues. And as long as you understand and you're able to identify the clues that the problem is giving you, and you've got a firm grasp of the relationship between the different clues, more often than not, you'll find that it's easy to calculate the final answer of what you're trying to find here. So let's do that. Let's start off with what we know. So here we have Sarah, who's a regular runner, and she knows that the distance between her house to the pond that she's currently standing at is 5.6 kilometers. She also knows that she can run at a speed of 3.4 meters per second. Now the question is asking us to calculate the time it took her to travel from her house to the pond. So this is something I think we can all envision. Now that we understand the scenario, I believe we can move on to the next step, which is to recall what we know about the relationship between distance, speed, and time. Now, if you've studied your formulas well, you will recall that distance is equal to speed multiplied by time. You should also know that speed is equal to the distance divided by time, and that time, therefore, is equal to distance divided by speed. If you're like me and you're not very good at memorizing these types of formulas, an easy way to remember this is the old speed, time, and distance triangle. The triangle is a very simple and yet effective way of remembering the relationship between distance, speed, and time. The horizontal line is there to remind us that whatever is above the horizontal line is meant to be divided by what is below the horizontal line. The vertical line is there to remind us that whatever is to the left and to the right of the vertical line is meant to be multiplied. So let's take distance, for example. We know that distance is equal to speed multiplied by time. If we refer to the triangle, we can see that in order to calculate distance, there's a vertical line separating speed from time. Therefore, we multiply speed by time. Again, if we want to calculate speed, we find that distance is above time, and there is a horizontal line separating distance from time. Therefore, in order to calculate speed, we divide distance by time. And the same is true for calculating time. Again, distance is above speed. There's a horizontal line dividing the two. Therefore, we are to divide distance by speed in order to calculate time. So you see, it's a really easy but effective way of remembering the relationship between distance, speed, and time. Now that we've been able to recall the appropriate formula, our next step is to apply what we know to the problem. The problem is asking us to calculate how long Sarah had been running by the time she reaches the pond. So in other words, we are to find the time. Referring back to our triangle, we know that in order to calculate time, we divide distance by speed. Now, we've been told that the distance between Sarah's house and the pond is 5.6 kilometers. We've been told that her speed is 3.4 meters per second. Now, there's a problem here, and I wonder if you're able to identify it. If you did, you'll recognize that we have kilometers and we have meters per second. So there definitely needs to be a unit conversion before we can apply the formula. We know that 1 kilometer equals 1,000 meters. Therefore, in order to convert kilometers to meters, we multiply 5.6 times 1,000 meters divided by 1 kilometers. After canceling out the kilometers, we find that the distance is 5,600 meters. Now, whether you convert it to kilometers or meters is arbitrary. We could have just as well converted meters per second for speed into kilometers per second. But I just decided that I wanted to convert kilometers into meters, and that leaves us with a distance of 5,600 meters divided by 3.4 meters per second, and that equals approximately 1,647 seconds. And depending on whether the unit you're looking for is seconds or minutes, we can convert seconds into minutes by dividing by 60 seconds, because for every 1 minute, there are 60 seconds, and that gives us approximately 27.5 minutes. So Sarah had been running for 27.5 minutes by the time she reached the pond. Thank you for tuning into our Tutoring Tuesday channel. If you enjoyed watching this video and found it helpful, please give us a thumbs up, comment, and subscribe. We would love to hear from you. Until next week's Tutoring Tuesday, happy studying.